Hello everyone, here are the notes for two-step stoichiometry. Make sure to look at the slides to grab the EQ. But otherwise, let's go ahead and get started. So far in class for stoichiometry, we've seen how to find the molar mass. So right here, we look at this part right here, the molar mass. We find it to go from, if we start with grams of substance A, we can get to moles of substance A. Okay, so, and remember that the molar mass we get from the periodic table. Okay, and that was where we find all of our information. If you can't remember any of these steps, go back. We have notes on molar mass and how to get it from the periodic table, and then we also have the molar mass stoichiometry. Okay. So from there, we also learned how to find the molar ratio. So molar ratio we get from to go from moles of substance A to moles of substance B. Okay, and this, the molar ratio, we get from the balanced chemical equation, right? And again, if you forget, if you're not sure, go back to the molar ratio stoichiometry. Okay, so from here, now two-step stoichiometry, and we're only going to go to two-step, we're not going to go to three-step, is putting it all together. Right? So that means that our conversion factors, we are going to look at two at a time. Okay, so now we're putting it together. We learned the pieces of the puzzle. Now we're going to put the puzzle together. All right. So the best way to do it, to learn how to do it, is do the example. So here we have an example. It says how many moles of H2 are used to produce grams of H2O. Okay, and then really quick, we are going to use this image here to find our path, because the thing is that there are certain steps that we have to go through in order to get from one thing to another. Okay, so like everything, I tell you all to find your number, right? So in this question, in the example, given the equation, how many moles of H2 are used to produce 10 grams of H2O, we are going to circle the number. The number here is 10. So we're going to circle it. And this is our start. Okay. And then after that, we are going to look for the word how many, right? How many, and that's going to give us our end. How many what? How many moles of H2? So let's go ahead and circle that. And this is our end. Our end or our final. Okay, so now, once we know where we're starting and when we're going, our start is always going to be our substance A, because we're starting from A to B. So our start is always going to be our substance A, And our end or our final is always going to be our substance B if they are two different substances. So right here we have H2O, and right here we have H2. So those are two different substances. That means first substance is A, second substance is B. Okay, so now we're going to start with step number 1. So we're going to circle the portion of the diagram from the problem. So that means we're going to look for grams of substance A. So if we look over here, grams of substance A is this first figure right here. Actually, let me turn that red. Grams of substance A. This is our start. And why? Because we got it from our problem. And now where is our end? Our end is moles of substance B. So let's go ahead and circle that, moles of substance B. Right here we see moles of substance B. This is our end. Moles of substance B. Okay, so this path is going to tell us what conversion factors we're going to use. So that means that we are going to use molar mass of our substance A, right? Make sure that you're doing molar mass of substance of the correct substance, because otherwise you're going to do the molar mass of substance B and then you're just going to do extra work that you don't need to. Okay, so we're going to find molar mass and the molar ratio. Those are our two conversion factors. Okay, so now let's go ahead and write out our conversion factors. So we have to figure out what are our, remember how I said Google Translate, we're going from one language to another. These are conversion factors are our Google Translate. So we have to find out what is our Google Translate for the first one and what is our second one. So let's go ahead and start with molar mass. And then what is our substance? Our substance A is H2O. So molar mass of H2O. Okay. So remember, to find molar mass, we have to list out all of our substance or all of our elements. So we have hydrogen and we have oxygen. So then from there, we are going to look at our periodic table, and hydrogen, its mass is 1.008. Oxygen is 15.999. Okay, and then from there we multiply how many elements in our compound. So hydrogen, we have 2 of them, and oxygen, we have 1. Right, and then equals. So 1.008 times 2, we have 2.016 grams. And then this is just 15.999. All right, so we add that all together and we get, okay, so we get 18.015 grams. And again, molar mass means that it equals 1 mole of H2O. Okay, that's the definition of molar mass. So this is our molar mass conversion factor. We have 1. Now we have to find the second one. So the second one is going to be molar ratio. So let's go ahead and do that. So our molar ratio, And where do we get that from? If you read right here, it says from the chemical equation. So it's our balanced chemical equation. So when we're looking at the molar ratio, we're going to look at our substances. So we have H2O, which is this one, and H2, which is this one. That means that for this problem, we're not going to care about this O2. Okay, so now our relationship is how many moles of H2O? So we have moles of H2O. How many moles? According to our chemical equation, we have two moles of H2O. All right, and now how many moles of H2? We have 2 moles of H2. And this is our molar ratio, our relationship. All right, so now we did the hardest part, the part that takes the most time. So now we will put everything together. So here's the question again. Using the starting value units, conversion factors determine the amount of moles of H2 used to produce 10 grams of H2O. Okay, so again, our starting value is this one right here, grams of H2O. It's also at the top, but I brought down the question over here. So let's go ahead and put that down. 10 grams of H2O. Okay, so now conversion factor number 1, if we look up, this is our molar mass. So the molar mass that we found for H2O, that's the first one that we're going to put down. So conversion factor is our molar mass. Okay, so remember, we have the gram side of our molar mass and the mole side of our molar mass. Which one are we going to put on the bottom and which one are we going to put on top? So if you need to, pause the video to double check and then continue. So remember that this part right here, the grams of H2O, here I'm even going to select this part right here, the grams of H2O, what we have here, we need to have down here in order to cancel out. So let's go ahead and put grams of H2O. And according to our conversion factor, how many grams of H2O? We have 18.015 grams. So we're going to go ahead and put 18.015. And then the mole side goes on top. So how many moles? By definition, molar mass is 1 mole. So we have 1 mole of H2O. All right, so now our second conversion factor. So our conversion factor number 2, if we go up, our conversion factor number 2 is going to be the molar ratio. Right, again, we got it from the chemical equation up here. Right, the 2 comes from the coefficient over here, and the 2 for H2 comes from the coefficient. So now let's go ahead and put it. We know that we have 2 sides of the molar ratio. We have to figure out which one goes on top and which one goes on bottom. So again, whatever's at the top, we have to put at the bottom because we want to cancel out. We have the moles of H2O. We want to cancel it out. So right here at the bottom, we're going to put moles of H2O. Again, because we want to cancel those out. So we look back at our conversion factor. How many moles of H2O? It says 2. We have 2 moles of H2O. And the other side of our molar ratio is, So we already put down this part. Now we need to put down this part. And so this one is going to go on top, 2 moles of H2. So we have 2. It's going a little bit slow. Moles of H2. Okay, so now the only thing that's left is putting it into the calculator. So before we do, let's make sure that all of the units cancel out. So grams of H2O cancels out with grams of H2O. Moles of H2O cancels out with moles of H2O. And we are left with moles of H2, which if we look back at our question, how many what? How many moles of H2? That's what we want to end with. That's our final. So let's go ahead and put moles of H2. Okay, so now let's just plug it into our calculator. So remember, we start with our first value, then anything on top we multiply, anything on the bottom we divide. So in your calculator, what you're going to put is 10 times 1 divided by, so the 1 is this one, divided by 18.015 times 2 divided by 2. So go ahead, put that into your calculator, tell me what you got. All right, so you should have gotten 0.555. It probably has more numbers like 0, 9, 2, and so on, but just put 3 decimal places. So as long as you have 3, that is good for me. So at the very end, how many moles of H2O? We have 0.555 moles, H2, moles of H2. This is our answer. Okay? And there we go. So we've already done this process. You are just going to put everything together. So now go ahead and pause the video, start with practice number 1, and I will have it complete. So pause the video right now, complete it on your own, and then continue watching the video to get the answer. All right, so let's take a look at what we got. We have All right, so right here, given the equation, how many moles of CO2 will be produced with 2.5 grams of CH4? So again, the value 2.5, that is our starting point, and it's grams of CH4. We start and we give it the A because it's what we're starting with. And then we look for the phrase how many? How many what? How many moles of CO2? This is our N, this is our final, this is our B. So then we go to our path, and we're starting with, if we look over here, we're starting with grams of A. So grams of A is what we circle, and then our end is moles of B. So moles of B is what we circle. So grams of A is our starting point, grams of B is our end. So then we look at, all right, what conversion factors do we need? So we need molar mass of A, and then the molar ratio to go from A to B. Okay, so now let's write down our conversion factors. So the first one is molar mass. My substance A is CH4. So let's go ahead and find the molar mass of CH4. Molar mass of CH4. In CH4, we have carbon and hydrogen. The mass of carbon is 12.011. Mass of hydrogen is 1.008. Again, we get these values from the periodic table. And then we have only 1 carbon in CH4 and then 4 hydrogens in CH4. So 12.001 times 1, we get 12.001. And then 1.008 times 4, we get 4.032. So we add that all together, and we should get 16.043 grams of CH4. And again, because this is molar mass, it's equal to 1 mole of CH4. Okay, so we are done with molar mass. So now our second conversion factor is molar ratio. So molar ratio, we are looking at our two substances. So let's look back, two substances is CH4 and CO2. So we're going to circle those. We have CO2 and CH4. So now, how many moles of CH4? We have 1 mole of CH4. How many moles of CO2? We have 1 mole of CO2. So let's go ahead and put that down as our molar ratio. 1 mole of CH4 and 1 mole of CO2. Okay, so now we are done with the hard part. Now we just have to put everything together. So let's go back to our original question. And our original question tells us how many moles of CO2 will be produced from 2.5 grams of CH4. So let's go ahead and put our grams of CH4 down. So grams of CH4. And then our first conversion factor is molar mass. We know that the grams have to cancel out, so grams of CH4 has to go on the bottom. And then the moles of CH4 has to go on top. And so let's start putting in the values. So how many grams of CH4 according to our molar mass? It is 16.043 grams. So let me go ahead and change the color. 16.043. Okay, and then the other side of the molar mass is always 1 mole. Okay, so now our molar ratio. So let's look back. How many moles of CH4? And again, moles of CH4 has to go on the bottom because we want to cancel out the units. Moles of CH4, moles of CH4, we want to cancel them out. So how many moles of CH4? We have 1 mole of CH4. So let's go ahead and put 1. Let's change the color. We have 1. And then moles of CO2, how many moles of CO2? We have 1. Right? So the last thing that we have to do is, put it all into our calculator, and we always start with the first number. Anything that's on top, we multiply. Anything that's on bottom, we divide. But before we put into our calculator, let's double check that everything cancels out. Grams of CH4 is canceled out by grams of CH4. Moles of CH4 is canceled out by moles of CH4. And the only thing that we're left with is moles of CO2, which is exactly what we want because the question is asking for how many moles of CO2. Okay, so now let's plug it into our calculator. You should start with 2.5 and then times 1 divided by 16.043 times 1 divided by 1 equals, go ahead and pause the video to find that answer. All right, and the value that you should get is 0.156. In your calculator, you might see 0.155H3 and so on. But remember, just leave 3 decimal places. And then if you see that third 5, right next to it is an 8. So the 8 tells the 5 to round up. And that's how we got this 6 right here. So 0.156. And then it's what? What does this represent? It represents moles of CO2. So 0.156 moles of CO2. And this is our answer. Okay, so you've already seen all of this. Trust yourself. Go through it. If there's something that you forgot how to do, go back to those notes. Molar mass, go back to those notes. Molar ratio, go back to those notes. and then just put it all together. Remember, the most important thing is that the units cancel out. That will tell you what order you put everything in. All right, good luck, everyone.